Thank you everyone else as well for taking the time to come and to see React Native London meetup. I'm Callum, I'm a developer at Fiodo, and I'm going to do a talk on monorepos with React Native. So let's look at what we'll cover. The four main things we're going to cover are the sort of use case for monorepos in React Native, why we've chosen to do them in the project I'm on, issues we've had setting that up, tools that made that easier, and then reviewing, was it really worth it? So before we get started on that, I think it's worth just asking the question, what is a monorepo? So I had a sort of misconception with monorepos, and I thought a monorepo is simply a backend, a front end, and maybe a database in separate folders just within one repository. And that's all a monorepo could be. But that is sort of a subset of monorepos and not the entire story. So the sort of definition of a monorepo could be a single repository that stores all of your code and assets for many projects. So that's slightly different from what I just said, because each of these projects could be completely individualistic. For example, Google basically has all of its projects in one repository, and that is considered a monorepo as well. Now, what I'm going to be talking about today is what is more of a traditional monorepo to me, which is multiple apps in one repository, but it's worth mentioning that it could be different. So a good tool and sort of website to discover about monorepos is monorepo.tools. I think this is a really new website. It's got amazing visualizations, explanations as well of what monorepos are. And one of its best features is it's got like these really cool comparisons between different monorepo tools. So definitely check it out. That's monorepo.tools. Cool. Another thing I'd like to just clarify is that like monorepos aren't the same as a monolith. So monoliths, when we talk about monoliths, we're talking about tightly coupled code, whereas a monorepo, these projects often can be used individually and they're logically independent. So a sort of example of a monolith might be a Ruby on Rails project where it handles the website, the API endpoints, and the background jobs all together. So yeah, now that we have like an understanding of monorepos, let's get some project context before seeing how we can build a monorepo architecture with React Native. So the client I'm working for currently was originally a magazine publisher. So back in the day, they had sports magazines, gardening magazines, football magazines, all of it. So yeah, they've got all of these types of brands. And now the digital revolution has obviously happened. So they started creating websites for each of their brands. Now, the really interesting thing here is that when they did this, they used shared APIs. So each of the websites uses the same API to fetch the content, the same API to log in, and the same API to save collections, for example. And now we're on to the next phase, which is our task, which is to build some apps. So we're basically tasked with building multiple apps for each brand. So to recap, we've got a load of different brands and different apps and lots of shared functionality between these apps. So we thought, a monorepo really would fit this use case. If we create a monorepo, we can have like a common shared folder of code that all of these apps can reuse code from, no copy paste and no redundant code. As well as we could have like a sort of config driven app system. And what I mean by that is that each app will have a config where you can change things as color systems, what different buttons say, but all apps sort of have a similar code base, which is really cool. And it allows us to spin up new apps, new magazines really, really fast. So let's talk a bit about how could we make a monorepo in React Native. So the first place we looked, because we weren't sure when we started this project, was the React Native docs. However, the React Native docs didn't really have too much documentation for monorepos. They did suggest in the Mac OS plus Windows OS documentation this kind of architecture where we have, a shared Android, iOS, Mac OS, Windows folders for the native code, and then a single source. And this is okay, and I think it works in a lot of use cases, but ultimately this is a single app that runs on different platforms, which isn't really what we want. We want multiple apps. So the fact that there's just a single package.json means all of these apps would have to use the same dependency versions. It's just not ideal. So we had a bit of a shop around and we came across Yarn workspaces. Now, Yarn workspaces is nothing new. Babel's been using this for ages for all of their packages. One of the basic ideas of Yarn workspaces is that you set up multiple packages in one repo. In our use case, each package would basically be an app. So we're going to have like a test app 1 here, a test app 2, and then we're also going to have a shared common folder for all of the shared code. And that in itself is also a package. So one thing that's worth pointing out really about this is that each app will have its own package.json. So that means different dependencies for each package, which is really awesome. But it's also worth mentioning that once we run yarn install, we'll get a node modules folder at the root level of the yarn workspace. And that basically means we can run yarn install once, and for every app, dependencies will be installed and all stored at the root level in the node modules. And that also has its own package.json for configuring yarn workspaces. Cool. So why do this? Couple of reasons. Firstly, having node modules at root level rather than in each separate app means that we have a single lock file, so less conflicts for version management. And it also means less duplicated dependencies because all shared dependencies between each app stay at the root level in the node modules folder. So what has this really become? This is from what we were before, which is a single app that runs on different platforms. We are now we have multiple apps that share common JavaScript code. And that's a really important thing that we needed for our use case. Cool. So how do we go about implementing a Yarn workspace? So it's actually quite basic. In the root directory package.json, we just need to define our Yarn workspaces like so. There we go. Just like this. So we have a common, a test app 1, and a test app 2. So test app 1, test app 2, again, are different magazines, and then common is where the shared code will be. So this is really useful. In each app, we'd need to add basically also common as a dependency. So because common is sort of like an npm package, we need to add it as a dependency for the shared code. And we just need to add that to each package.json for each app. Cool. So once we start doing our build, we're going to run into issues. For example, there we go. So for example, we're going to run into this kind of issue when we do pod install. It's pretty cryptic. I wouldn't read it if I were you. There's no point. Put it that way. It won't get you anywhere. Unfortunately, we're going to have this like sad cat, and you're just going to be left confused like I am. So the hint I will give about this is it's a hoisting issue. So I'm going to do my best to explain hoisting and why this is an issue, but it's a pretty lengthy discussion. We'll give it a go. So before we sort of discussed how node modules would be at the root folder of the directory, right? And this is a result of hoisting. So what is hoisting? Well, in monorepos, we have multiple packages. Here, package 1, package 2 would be test app 1, test app 2. And then we're going to have multiple different dependencies scattered across these packages, right? So the idea of hoisting is to flatten these dependencies and hoist them up to the root node modules folder. And this looks like this. Cool. So why would we do hoisting here? Sort of basic explanation is that if we have multiple apps, then really dependency trees can get very complex. In this diagram, we've got a simple dependency tree. We've got a couple of packages. You've got A, 1.0, etc. These are all dependencies. There's only a couple, but we all know that in real apps, there's thousands of npm packages everywhere. So it can get really complex. So hoisting allows like this to be simplified. And then the other main benefit is that it reduces the amount of copies of modules. So brief example here, we've got package B 1.0. It's used both by package 1 and package 2. Once that's hoisted on the right, you see that it just goes to the root node modules and it's deduplicated. It's only there once. So we're reducing redundancy, which is really cool. So we're keeping the tree nice and flat and nice and simple. Now, not all modules go in the root node modules. You might have noticed B 2.0 doesn't get hoisted in a traditional sense, right? It's staying in package 1. Now, why is that? So there's a couple of reasons this could be, but the main reason is that any dependencies that already exist in the node modules, for example, B 1.0, but have a different version. Here we have B 2.0, so it's just a different version of the same dependency. They shouldn't be hoisted to the root node modules. It's going to get confusing, right? Because you're going to have different versions in the same node modules. It's kind of confusing. So it will stay in the package where it is, and then we can access that. Basically, when we do a pod install or anything like that, we access from the root node modules, and then we do this really cool thing called symlinking to get to that B 2.0 package. Now, what is symlinking? I never knew what this is until I started this project. It sounds really complicated. It's basically like a Windows shortcut. My friend gave this analogy yesterday, and I thought it was brilliant. It's basically just a pointer. It points to, for example, in this one, it just points to package 1 from the root node modules. That's all it does. So we can access it through the symlink. Cool. So now we understand a little bit about what hoisting is and what symlinking is. Why was this happening? Well, to recap, as a result of hoisting, dependencies are fetched from the root node modules folder. And any modules that aren't in the root node modules folder are fetched via symlinking. Now, why is this an issue? Well, native code, unfortunately, can't follow symlinks. So sometimes native code in iOS or Android maybe needs to reference something in test app 1 or test app 2, but it's trying to do that through the root node modules, and that's just not possible. Native code can't follow symlinks. So what can we do about that? Well, there's this really nifty thing called no hoist. Basically, it's a setting that disables the selected modules from being hoisted to the project root. Now, this allows us to access modules we can't access from the root node modules. It cuts out the symlinking. Because they aren't hoisted, it means we gain back some duplication, however. So we sort of need to be careful and manage this. The aim, ideally, is to keep this no hoist list as small as possible. Now, you might have noticed that React Native is appearing twice in a no hoist list. So the first instance basically tells Yarn that the React Native library should not be hoisted. And the second instance, with the additional ** afterwards, tells Yarn that that React Native's dependencies, for example, Metro, React Native CLI, should also not be hoisted. Sometimes it's just easier to not hoist like this. So it's a useful thing to know. So we've done this. We've got the no hoist list. We're ready to build. We can do our pod install finally with no errors. We're ready to start developing. The sun is shining. It's time to spin up the simulator and get developing. Except we're going to get into bundle errors next. So unfortunately, we thought we were done with any issues, but unfortunately, hoisting issues are going to crop up again. Now, this time, I just show this not again meme. So this time, it's not native code causing issues. This time it's Metro. So the Metro bundler comes with React Native and bundles the code for us when we want to run in the simulator or do stuff. Now, this is Metro's most famous limitation, and it's that Metro cannot follow symlinks. It's actually the first ever issue Metro had. It's still open, and they have no plan to fix it. So we can't really rely on Metro to follow symlinks here. It's just not possible. So what's going to happen? What's happened this time? It's actually interesting that it's the opposite of what was happening before with the pod install issue. So when we were doing the pod install issue, we were trying to access, for example, test app one modules from the root node modules. Now this time it's the complete opposite. We can't access the hoisted root node modules from test app one. Metro can't see outside of its own package, basically. It doesn't know how to get outside. How can we fix this? Well, this brilliant guy, Matteo, has developed a really, really useful library, React Native monorepo tools. So what this does basically is makes Metro aware of the node module directory outside of test app one. So not only does that allow us to see the root node modules, but it also allows us to see our shared common package that we're going to be using a lot. So all that's really needed to do that is we need to update our Metro config file like so, and just add for watch folders, monorepo Metro tools, the watch folders, and let the library do the rest, really. So we finally did it, guys. We're ready to develop. The sun is actually shining. We made it. That's the main issues that we really had with monorepos and setting them up. So I thought it's worth talking and discussing a couple of other features that will help improve the dev experience. So these aren't things that fixed issues exactly, but they help the dev experience. So one thing we're using is Bob Build. Now, Bob Build is an interesting one. We're using this in the common shared folder. And usually in React Native, we just compile code at build time with Metro when running the app. Now, what Bob Build lets us do for our common shared folder is build and transpile our code to common.js and also generate type definitions for our common shared folder. That means we can use the types and stuff outside of the common and use it like an npm package, basically, because that's essentially what the common shared folder is acting as. Now, this really helps us because it keeps our options open in the future. Say we wanted to ship this as a private npm package. We've already got this Bob Builder set up. Happy days, really. So how do we use it? Basically, just inside the common package folder, we need to add this to our package.json again. So all this is saying really is in the source. So that's where we want to transpile from. And then our output is the sort of the end folder where the build will go. And then the targets is just saying things that we want. So for example, we want to transpile to common.js and we want to have type. Now, that's a really cool feature. And then another thing that we use, interestingly enough, is Learner. Now, Learner itself is actually a tool for managing multi-package repositories with Git and npm. So it's a monorepo tool itself. But we don't really use it as such. The only feature we use of Learner is to run things in parallel. So that's testing, type checking, and linting. Why do it one by one when we can do it in parallel? Speed up that build times, the CI/CD, improve the dev experience. Now, this is basically all we use Learner for, and it's quite interesting, really, that it works very well with Yarn workspaces. One might think that they would be incompatible. However, that's not true. They work really well. Good to know. So apart from these handy tools, I think it's worth discussing in reflection so far in the project, the positives and the negatives. So what really went well with the monorepo approach is that for our use case where we're sharing tons of code for different magazines and they're really using the same thing and it's just a customizable config driven app, it means that we can edit that common shared folder in the same repository. We get easy visibility of the code. It's all in the same place. And we don't need to play around with private npm packages, as I'll get onto in a minute. Now, it also means we can bootstrap new magazines apps really fast. Say they buy a new magazine and they want to start shipping something straight away. All we really need to do is provide it a config and a couple of routing things, and then they're ready to ship. So it's super fast dev experience. Now, there is, of course, some negatives. I'm sure I made it clear that these errors that we're getting are really cryptic. Sometimes it doesn't really feel like they have anything to do with the error. And like I had to spend, and my team had to spend a lot of time sort of configuring and debugging the build process to get it right. So it's a lot of upfront cost in terms of time and resources. Another sort of issue we've been experiencing recently is our CI/CD. So we're using Bitrise. Doesn't really seem to support monorepos in the way we want. We'd ideally want just one Bitrise and have multiple sort of deployments coming out of that. We're probably going to end up with doing multiple Bitrises within just one repository, but it's not ideal. We wanted it to be one shared place so we can manage it all in one rather than having it nice split up. So that's unfortunate. Now, you might have already asked, like, why not the privately shared NPM package? What's wrong with a private shared NPM package here? Well, so it's quite interesting. We've had teams at Fiodo do it before, and it ended up being pretty cumbersome. For example, say you wanted to make a change in the shared common folder. Now, that's going to be wired up as a private NPM package for publishing to start with. But you're then going to, every time you want to change or test it locally, you're going to have to rewire it for local testing and then rewire it back to publish. So it just adds a lot of time. And I feel like the dev experience isn't great for that. So for us, we felt like whilst we're making constant changes at the start of the project, it makes sense to just have it within the monorepo for easy and fast changes and instant responses. Now, this does have some advantages though. So it's not like we've completely dismissed it. We feel like it may be a good idea once we have a solid foundation for the apps and it's more of a maintenance mode. So a big advantage of having like these privately shared NPM packages is the good version management. We could, if we wanted to, have certain magazine apps be a different sort of version for the common shared code to other apps. You could have like 1.0 for your sports mag and then 2.0 for your gardening mag, and easy to roll back as well. So in terms of version management, it would be useful to have, and it's something we're definitely looking at doing in the future. So three key takeaways for this talk is that monorepos in React Native work well with lots of shared code between apps. So we've really experienced like fast developer speed and easy visibility. I really feel like it's been a pretty good success in terms of that. However, I would say if you had two entirely separate apps within a monorepo, is it really worth it? If they only had like a bit of shared functionality, for example, they might have like spaces or something, is it really worth that upfront cost of configuring the build to have it in a monorepo? Perhaps not. I think in our case, where we've got lots of shared code, it's really worth it. That's definitely something you'll have to consider going forward. Now, again, the second bullet point, React Native really struggles with symlinking, whether that's native code or Metro. Symlinking doesn't want to work, and it's going to cause a load of issues to do with hoisting. But hoisting is really awesome. Like it reduces complexity and reduces redundancy. So we really want to keep that no hoist list as small as possible. And then finally, tools do make things easier. You know, Yarn workspaces, no hoisting, React Native monorepo tools, just to name a few, have really helped. And I'm sure there's other tools that we haven't even yet found that are just going to help just as much. So I do think like monorepos have a really good future within the React Native ecosystem. And I'm really excited to see what comes out next. Cool. Thank you for the talk.